Hello and welcome back. In this video, we are going to conduct a test, the third chi-square test, that is chi-square test for testing the association of proportions. The chi-square test for testing the association of proportion is nothing but an extension of the chi-square test for independence, or otherwise test of association. And what we tested in chi-square test for association, whether a particular number of category, whether the number of samples in a particular category exactly coincides with another category. In proportion, what we are testing, the proportion of the percentage of samples in a particular category coincides with another one. Then what would be the test result? What would be the null hypothesis? The null hypothesis is nothing but the proportions are not associated, or otherwise the proportions are unrelated. I am going to use the same set of variables that we have used for chi-square test of independence, that are income and duration of cyber cafe visit. How will you get it? We will follow almost 80% of the chi-square test for association, analyze, descriptive statistics. From descriptive statistics, we will go to cross-tabulation. From cross-tab, we will load the variables of our interest. So, income on the row and duration on column. Then from this one, we just selected chi-square here. Yes, chi-square we selected. We have to go one step more comparing to the previous one. That is, we have to locate cells. So, when we click on the cell radio button, we will get a window like that. In this one, locate the percentage. Tick in the row. When we tick in row, we will get all percentage expressions of the variable that we have entered in row. And if you are looking at only the percentage of that variable, vis-a-vis the other one. And if we select column by deselecting row, we will get only the percentage of the variables that we have entered in column. What if we select both? If we select both, we will get the proportion between these two variables. So let's see, for out of curiosity, we will just see how this appears. We will click continue, then everything is okay, then we will click OK then. Yes, we got the result, this result. So this is the table we have received. And in the previous one, when we conducted the previous test, that's the test of association, we got the cross-tabulation table only the first row in every cell. First row, 7, 16, 1, 1, 32, 45, 3, 0, like that. But now we have got two rows in addition to every, as an addition to every cell, that is percentage with income, this is percentage with duration. So this is the variable in row, that is 28%. What does this 28% mean? This 28% mean out of the total respondents who have less than 10,000 as their monthly income, 28% of the samples who have less than monthly income visit internet cafe or have been visiting internet cafe less than 30 months. And what does this 64% mean? 64% means 64% of the respondents who have less than 10,000 as their monthly income have been visiting cyber cafe 31 to 60 months. And what does this 6.2% means? The 6.2% means out of the respondents, 6% of the total respondents who visit cyber cafe between 31 to 60 months have got income 10,000 to 19,999. So this way will express both column wise and row wise. So this is nothing but the status of the distribution. Our variables of interest, our output of interest, results of interest is lying here. Here, in the proportion, what we have seen, the Pearson correlation coefficient is not statistically significant. Since it is not statistically significant, we fail to reject the null hypothesis. Then let's recall, what was our null hypothesis? Our null hypothesis was the proportion of these two variables, the proportion of both income and duration of visiting cybernet cafe is not equal. So that is the implication of this. Since the significance value is more than 0.05, there is no statistical significance or there is no empirical proof to reject the null hypothesis. So we can't say the proportion are same, the proportion are different. And from this table itself, we can understand the proportions are different in different rows and columns or different cells. And where is the possibility, where is the room for assuming or concluding they are equal? They are not at all equal. So this is chi-square test for the proportion test. Let's recall what we covered in this video. And in this video, we were covering that whether the proportion of a given category of sample is equal or not equal with that of another category.